All of our discussion was based on what is known as perfect information. Reality isn't this straightforward. In fact, this is what makes business situations challenging. Suppose you're a manager in a company whose employees come from diverse educational backgrounds. You can think of the automobile sector. You would like to find out how likely it is that a manager at the company is college educated.
Hmm. That's like probability of C given M?
That's correct. It's reasonable that you would know such things as how many people work at your company, but you wouldn't go around asking each manager whether they've completed college, right?
I wouldn't. That's sensitive stuff.
That's what makes calculating our likelihood P of C given M quite difficult, if not impossible. Let's now talk about how we can get some rough idea of this. Say you're a popular manager with a large circle of friends whose backgrounds you know fully well. This means you've got a good handle on the priors, which are P of S, P of PS, and P of C for the three educational levels. You'll easily know which of your friends in these three camps are managers. So you can even calculate three proportions. They are the likelihoods P of M given S for school, P of M given PS for post school, and P of M given C for college.
I'd be willing to bet the more someone's educated, the better their chance to be a manager.
For our convenience, let's assume the same probabilities and likelihoods that we have in our data set. Our prior P of M turns out to be 13.23% and P of C is 25.16%. From the margins, we can calculate P of PS post school as 62.44% and P of S as 12.4%. We have already derived the posterior P of M given C as 25.37%. I also leave you to figure out why these don't add up to 1. We are now ready to answer our big question. Remind us about it, Lisa.
What is probability of C given M?
Thanks. We must apply the Bayes rule, but the derivation of this rule was left to you as an exercise so you know why this works. Our inversion formula gives us what we need, and that is what you see on the screen. Don't worry, it's not as complicated as you think it is. And that's because we have all these numbers on hand. We get the numerator as 25.37% times 25.16%. The denominator is a sum of three products. We could have simply worked with decimal expressions, but percentages gives us a cleaner picture of probabilities.
Did you know percent is per 100?
Yes, so we drop the percent sign, work with the numbers directly, and get the ratio finally as 638 over 1324, which gives us 0.482 or 48.2%. If we had perfect information, we would simply look up the manager's row and revise the prior P of C, which was 25%, with the posterior P of C given M as 1925 over 3991. This would give us 48.2%. Whenever we impose a condition, our sample space shrinks in size. Just look at the Venn diagram, which is nearly drawn to scale. If we want to calculate P of C given M, the overlap M intersection C should be contrasted against the smaller region carved out by M. The figure explains why a prior probability of 25% went on to become 48% or nearly double. That brings us to the end of our discussion on Bayes' rule. we've designed a set of exercises so that you can get more acquainted with this important result.
We can only bid you a conditional goodbye.